Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called This is Jeopardy! Well, it's actually just Jeopardy. But it reminds me of the television show I used to see as a kid, and it was pretty actually a quite pretty fun show. Um, you'd always think that hey, I'm smarter than these guys, right? Because I know these solutions, but I've heard it's a lot harder actually doing the Jeopardy because you have a time constraint and you have to buzz in well in advance. I don't know if they can actually see the actual like clue though too, or if it's just read to them. If they could see the clue, then that makes things a lot easier because we see it, some people are visual um, digesters, I guess. I don't know. Knowledge. It's easier for us to digest knowledge visually, and I'm one of those that is better at look at being able to see things and being able to understand what that means. Versus when you have someone talking to you, some people are very good at actually receiving that knowledge from the actual words that are used and getting that knowledge that way. I am not one of those. So, after spending a lot of college years listening to things, it always was better for me to be able just to see something and then basically comprehend that knowledge from the visual than the audio. Anyways, this is Jeopardy by Katie Splendor. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have disjoint sets, where the digits in gray squares, or actually, I guess it's just called disjoint. It's not really disjoint sets. Disjoint sets are something else. But the digits in gray squares form a set of the digits 1 through 9. And there should be 9 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are all distinct digits or unique digits because they form a set of the digits 1 through 9. We also have Jeopardy lines, where each purple Jeopardy line is either a Dutch whisper line, where neighboring digits differ in value by at least 4, or a parity line, where neighboring digits switch between being odd and even. And no line may satisfy both conditions anywhere along its length. Oh, that's interesting. So either the Jeopardy line is a Dutch whisper line, which I will be calling whisper 4 lines because that's come up from sort of designation a setter created, which I thought made a lot of sense because it's very easily extensible. Or it's going to be a parity line. So say this Jeopardy line was a Dutch whisper line, and say we had a 3 here, then this digit would have to be 7, 8, or 9, because those are the only digits 4 or more away from 3. But it actually cannot even be 8, because no line can satisfy both conditions anywhere along its length. And if this were the case, if this were 3 and 8 here, that would be satisfying both the whisper 4 possibility, because the difference between the digits is 4 or more, and it would satisfy the parity condition, where you neighboring digits must switch from being between being odd and even, right? This is odd, and therefore that's even. So no, so if this were a Jeopardy line, sorry, if this were a whisper 4 line, if this were 3, this would have to be only 7 or 9. If this was a parity line, obviously it could be 2, 4, 6, but it could not be 8, because then that would also again satisfy both conditions, which it's not allowed to do on the whisper 4 line or the parity line. Interesting. Branching Jeopardy lines maintain the same condition throughout. So that means this is basically the same. These must satisfy one or the other of the rule, and that's it. It cannot basically, same with this. These cannot switch to a different type of line here. They have to have the same parameters throughout here. Interesting. Digits may repeat on lines if allowed by other rules. So examples of legitimate Jeopardy sequences. Right. So this is going through that. Can this work here? Let's say this. 2, 8, 4, 8, 2, and 6 is valid for a Dutch whisper or a whisper 4 line, right? Because none of these change parities here, right? So we have 2 and 8, 4, 8, 2, 6. So this would be valid as a whisper 4 line, right? Because their differences are always 4 or more. Another example would be something like 1, 5, 9, 3, 7 along the line for the whisper 4 line, right? Because they have a difference of 4 between neighboring digits, and they don't alternate between odd and even for those digits. An example of a valid parity line would be something like 1, 4, 5, 8, 7, 6, 3, and 4. Because these alternate different parities on the parity line, and no two digits on this line have a difference of 4 or more. An example of an illegitimate sequence, it would be 1, 6, 2, 5, 9, and 2. Since there are both parity switches and Dutch whisper pairs, right? Yeah, this is this difference switches parity 1 and 6, and there's a difference of 4 between them. So that satisfies that. 9 and 2 also has that situation where 9 and 2 have a difference of 4 or more, and they switch parities, which is not allowed on these Jeopardy lines. And those are examples of how the Jeopardy lines work. We have XV sums, where digits separated by a V sum to 5, and digits separated by an X sum to 10. No negative constraint. So, for example, say this was a 1 here. This would have to then be a 4, because these two digits must add up to 5, because there's a V between them. If we had, say, a 3 here, this would have to be 7, because these two digits must add up to 10, because there's an X in between them. And finally, we have crop key dots, where digits separated by a white crop key dot are consecutive, and digits separated by a black crop key dot are in a 2-to-1 ratio, and there is no negative constraint. So say this was a 2 here. If this was 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio between them, because there's a black dot between them. If, say, this was 6, this would have to be 5 or 7 to be consecutive with a 6, because there's a white dot between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, to add up to 5, first of all, it's going to have to be an odd and an even digit, which means parity, and you can't have a difference of 4 or more between the two digits, because it's either 1, 4 or it's 2, 3. So this is always going to be a parity line here. So this is always parity. We'll mark those as random ones. So let's make it orange and yellow. So we'll make this orange, that's yellow. This is orange. We have yellow here. This is orange, orange. So that makes this yellow, which makes both of these orange, which makes both of these yellow, which makes this orange here. Okay. These have to be 1 through 4, so must these. So we know we cannot have a difference of 4 or more with between digits on this parity line. So this is at most a 7, but it's also next to a black Kropke dot. And black Kropke dots can never have a 5, 7, or 9 next to it. Because 5, 7, 9, if you have them, you get 2.5, 3.5, 4.5. If you double them, you get 10, 14, or 18, none of which are digits. So this has to be 4 or more, less away from these digits. So that means it can be at most 7 again, but it actually can't be 7. So this is 1, 2, 3, 4, and 6 here, which makes this 4, 6, 7, 8, or 9 here to add up to 10 with that digit. Anything with an X on them have to be the same parity. And since they're the same parity, these cannot be the parity line. So they have to be a whisper 4 line, which means they must differ by each other by at least 4. So you could have 1, 2, 3, or 7, 8, 9. The only pair of digits adding up to 10, which cannot be on there, is 4 and 6. So this is 1, 2, 3, 7, 8, 9. They have to have a difference of 4, and they have to be the same parity. Interesting. So okay, we don't know anything about these. These are two different parities. So these are marking parities here, right? These have to be the same parity to add up to 10, right? It's either 1, 9, 3, 7, or it's 2, 8, 4, 6. So this must be orange parity. We have 4 of the same parity here. Of the orange parity in box 9. Sorry, box 4. I was thinking of 9 because of certain things. This is yellow, so this has to be orange parity also, which means this must be a whisper 4 line here, right? Because if this is not whisper 4 as a line, well, to work as a same parity line, or a parity line, these would have to be different parities, and they're both the same, right? Because yellow, next to a V, they have to have different parities. That's why we knew this was a parity line here. But it's the same thing here, right? So we have orange, yellow, orange, yellow. That makes this orange. And orange, and next to a 10, they have to have the same parity. So orange is here, which forces that to be orange. So this has to be a whisper 4 line. This cannot be 4 because that's not 4 or more away from this digit. So this must be, it's not 4, this is 6. So interesting. That means these all have to be the same parity. So these are all orange. Because you cannot have them swapping parities either. 1 through 4 would have to be next to 5 through 9 here. 6 through 9 would have to be 1 through 5 here. And this digit would have to be 4 or more away from both of these. And the way that this is constructed, so normally, if you had all even digits here, the problem with that is that all the even digits cannot form a set of 5 digits and be in 4 or more away from each other. So try to imagine this. We have 2, 4. This would be 6 or 8 here. This would be 6 or 8. So we'd have a 6, 8 pair here. That can only be next to 2 and 4. But 2 and 4 are not going to be 4 or more apart from each other. So that's not going to work if orange is essentially if orange were even. So orange has to be odd digits, which means this can't be 2 or 4. This can't be 2 or 4. This can't be 1 or 3. So we have 2 or 4 here, 2 or 4 here. This must be 1, 3 as a pair here. That makes a 7, 9 there. 1, 3, 5 there. This is 7, 8, and 5, 7, 9 there. 1 and 3 is in a 1 to 2 ratio with 2 or 6. So this has to be yellow. So oranges are odd and yellows are even. This has to be 1, 3, 5, or 9. It cannot be 7. If we had 7 here, that's not going to be 4 or more away from 5, 7, or 9. So orange has to be... So we have... We have 3 oranges in row 4. This could be orange, but then we would also have to have an orange there. And if we try to have an orange here... We can't have it all. So this cannot be full orange and it cannot be full yellow. Because orange, that would require 6 odd digits in row 4 when we only have 5 available. And it would require 5 even digits in row 4 when we have only 4 even digits available. Oh, this is even, so this has to be odd here. We have 5 odd digits in row 5, which means the rest are even. So we have to have 1 even here, because again, you can't have 3 odds here. So therefore, that forces this to be odd, because that's 4 evens accounted for in box 6. And since this is 1 even and 2 odds, this must be an even here. And this is odd next to odd, so this has to be a whisper 4 line. So these are odd. It's the same situation here. We have 5 odds in box 5, so this can't be odd, it's even. This is odd, which forces this to be even, so all of these digits must be even to be on the whisper 4 line, because we know this is a whisper 4 line because these 2 digits cannot have different parities. So this has to be even, which makes this a 2, 8 pair. This cannot be 3. These are whisper 4 lines, and they're all the same parity. They cannot be all odd, because we would have 6 odds in column 7 then. So these must be all even. So again, this has to be a 2, 8 pair here. 2 and 8, which forces this to be 4 or 6. We have 4 even digits in the disjoint set. I don't even know if it's necessarily a disjoint set. But we have 4 of them, so that counts for all the even digits in that set. So therefore, this must be odd left. This is 2 odds and 1 even. We're not sure which is which. Can this be this cannot have 2 evens here. So either this is 3 odds or this is an even and an odd. This is 1 or 3, which means this is 2 or 6 here. Because this is an odd, which is next to a black crocky dot. The only odd digits which can be next to black crocky dots are 1 and 3. We have 5, 7, 9 here, which this digit is consecutive with that, so it's 4, 6, or 8 there. These have to be 4 or more away from each other. This has to be a parity line because we have one even and 2 odds there, and it can't satisfy both. So this must be even, which makes both of these odd to be a satisfactory parity line. Okay, we have 1 odd, 1 even there. So this has to be 4 or 6 here. We cannot have 9 here because that's 4 or more away from that digit, which would be 2 or 4. This is 5, 7, or 9. So if this were 4, that would mean this would have to be 5, this would be 7, and that would be 9, but then these would be 4 or more away from each other, and it cannot satisfy both conditions. So this cannot be 4 here. It's 6 or 8. So we know this digit. Okay, so let's look at possible digits. This digit, we'll mark it as A, is this cannot be this one, so that's B. Therefore, this is A here, which makes that B. Oh, these digits are the same. So Z and Z are the same because they're the only digits that can be in 1-to-2 ratio with those digits. Do they see anything else? Not really. So this is B. Obviously, B cannot be here. Z is here. So Z cannot be in any of the other any other disjoint sets. Don't really have anything there. This can't be 1 or 3, so this has to be 5, 7, or 9. Cannot be 9 because that's going to be 4 or more away from 2 or 4. So we have 5 or 7 there. A, where is A in the disjoint set? So I guess A could be here. A cannot be here, so A has to be one of these two. Okay. These have to be 4 or more away from each other, so 1 or 3 forces this to be 5, 7, 9. Okay. Okay, where can 2 and 8 be? In box 9. 2 and 8 cannot be here or here. We have at most one yellow digit here. We have at most one yellow digit here. Okay. These have to be 4 or more away from each other. Hmm. Um, hmm. If this were 6, that would force this to be 4. So these digits are different. So this Z digit cannot be here or here. So Z has to be one of these two. We know Z is there, so Z cannot be here. So Z has to be one of these two. Okay. Z can't be here or here. So Z is one of these 4. Okay. This digit, this is, so these digits have to be the same. So we have Y and Y here because A and Y add up to 5. So this A and Y must add up to 5 also. So Y is here, Y is here, Y has to be one of these two. A is here, A is here, A has to be one of these two. Interesting. Hmm. Hmm. Does that tell us anything? I'm not really sure. If this is 2, that makes this 1. Oh, this can't be 2 and 1. That would force this to be 3 and 4 trying to add up to 5, which is not possible. So 2 cannot be here, therefore this is 6. I guess we'll just remove Z. So this has to be 6. These are both 6. These are both 3s, so B's are 3. And A's have to be 1. We don't know which one. So A's are 1, and Y's are 4. So that means 4 here. 6 cannot be here because of the disjoint set. So this is 8. That leaves this as a 2. This can't be 2 anymore. It's 8, which makes that 2. 2 is 4 away from 6 out of 4 and 6. So this is 6. This can't be 8 because of 8 in the column. So this must be 6 to be 4 away from 2. Okay. 4, this can't be 6 because of 6 in the row. So this is 4. 4 cannot be here. It has to be 4 or more away from 6, so that makes that 2. 2 has to be 4 or more away from this digit, so this cannot be 8 or 2 here. It's 8, which makes that 2. 3 has to be 4 or more away from both of these digits, which is a 7-9 pair. 1 has to be 5, this 5, 7, 9. 3 eliminates 3 here, so it's 1 or 5. 1 eliminates 1 here. So, we don't really know what that is. 2 can't be here, therefore it's 6, which makes that 2. These digits have to be less than 4 or more away from 2, so it has to be a 3-5 pair, which eliminates 3-5 in the rest of the row and box, so this can't be 5, it's 7-9. This 7-9 pair eliminates 7-9 in the rest of the row, so this can't be 7, it's 5. These have to be 1, 7, or 9 here. 1, 7, or 9. 1 is one of these two, obviously. One of these is 5, but we don't know which. Well, 5 could be next to 9. No, 5 here would have to be next to 9 and 9 here. And then this 9 would have to be next to a 7 or 9 here, which is not going to be 4 or more away from. So this cannot be 5. This is 1, which makes this 5. This is 3 and 7 to add up to 10. That makes this 9 here. That's 7. That's 9. So this cannot be 9 here. If this were even, it cannot be... Well, 6 can't be either of these, so 6 has to be here. 1 is going to be 5 or more away from 6, so this has to be 7, which makes that 1 there. Also, 7 has to be 4 or more away from that digit. So the 7 eliminates 7 here. It's 9. This is 1 and 9, therefore this must be 5. So we have 1, 3, 5, and 9 in the disjoint set, so this forces that to be 7. 5 eliminates 5 here, so it's 3 and 5. Remaining digit here is 2. Remaining digits here are 4 and 8, which makes this a 2 here. Okay. Twos. Where is a 2 in column 3? Can't be here because of 2's in the boxes. Can't be here. That's filled. Can't be here because of 2 in the row, so 2 has to be here. 7 eliminates 7 here, so it's 5. Remaining digits in row 6 are 8 and 9. Remaining digits in column 7 are 4 and 7. Interesting. Remaining digits in column 3 are 6 and 9. And this can't be 6 because of 6 in the row, so we have 9 here. This is 6. If this is a parity line, this has to be even and would be 8. If it's not a parity line, it's a whisper 4 line, and it would have to be 4 or more away, but it can't be 1 or 5, so this would be 3. So we have 3 or 8 here. If this is a parity line, this cannot be 1, 5, or 7, and it can't be 3, because that would be 4 or more away from 8. So then this would have to be 9. If this is a whisper 4 line, we have 3 here. So this is guaranteed to be orange. This is yellow. We have 4 yellows in box 7, so the rest of the box is not yellow, it's orange. We have 5 oranges in column 1. That means the rest of column 1 cannot be orange. It's yellow, which makes this not yellow, that's orange. Okay. So therefore this is 8 and this is 9. This becomes a 4, 6 pair. This can't be 6 because of 6 in the row. So that's 4 there. This is 6. If this is 3, this cannot, again, I think either way this has to be 9. Right? If this is a whisper 4 line, 3 can only be next to 7 or 9, but 7 can't be here because of 7 in the row. So this is guaranteed to be 9, period. Okay. remaining digits. 8 can't be here, and this can't be 2, 4, or 6. So therefore, this must be an odd digit. Cannot be 1, 5, 9, 7. So this has to be 3. Interesting. 8 cannot be any of these digits here because of 8 in the box, and this can't be 2, 4, or 6. Therefore, these are both odd. Okay. Remaining digits of row 3. We have 4, 7, and 9. This cannot be 7 or 9 because of 7 or 9 in the column. So this must be even and is 4. That leaves odd digits as the remaining digits in row 3. We have 4 even digits in column 6, so the rest must be odd. And these are 7 and 9. This can't be 7 because of 7 in the column, so this is 9, which makes that 7. We have a guaranteed 4 here. We're not sure which. One of these must be 8. That's not that helpful, though. 1 and 7 cannot be here in column 1. Where are the 1 and 7 in box 7? It has to be here. So we have a 1-7 pair here, which eliminates 1 and 7 in the rest of the column. So this has to be a 5-8 pair here. Therefore, this must be 3, 5, and 9. This can't be 5 or 9 because of 5 or 9 in the row. So that's 3, which eliminates 3 here. Okay. This is 4 or 7. Well, that's not that helpful. If it's 4 and it's a whisper 4 line, well, yeah, that's a problem. It's it's not that restrictive. So, remaining digits in column 4. We have 3, 7, 8. 8 cannot be here because of 8 in the row, so this is guaranteed to be odd. Remaining digits of column 7, they're all odd. So it's 1, 3, 5. That's not too helpful. Remaining digits of row 7, we have 1, 7, and 8. 7 cannot be either of these because of 7's in the column. So this is a 1-8 pair, which eliminates 1 and 8 in the rest of the row. So this can't be 1. This is 7, which makes this 1. Therefore, this cannot be 1 here. Remaining digits in column 5. We have 1, 4, 7, and 8. 4 cannot be here because of 4 in the box. 7 can't be here because of 7. And this 5 eliminates 5 here. We have a 1, 3, 8 triplet in box 2, which eliminates 1, 3, 8 in the rest of the box. So this can't be 1 or 8. It's 7, which is odd. That eliminates 7 from the rest of the column. 8 can't be here because of 8 in the row. 1 can't be here because of 1 in the row. So this is guaranteed to be even because it's 4 or 8. Where is 2 in... Well, we have 8 2s, all right? 1, 2, 3, 4, 5, 6, 7, 8. We know where the last 2 has to be. It has to be there. So that's 2. This cannot be 3 even digits. Where is 6, actually? We should have 8 6s, right? We do. We know where the last 6 has to be. It has to be here. And because this is 6, this cannot be 3 even digits here. Because we have an 8 guaranteed in one of these and a 2 here. Well, that eliminates 2 of the even digits, and so this can no longer have 3 even digits. So this must be even a parity line, with this being even, odd, even. And since this is even, this is odd. We have 4 evens in row 9, therefore this can't be even, it's odd. We have 5 odds in box 8, so this can't be odd, it's even. We have 4 evens in row 8, this can't be even then, so this is odd. Anyways, so this must be 4 here, that makes this 7. 4 eliminates 4 here, so that's 8, which forces this to be 4 there. 7 eliminates 7 here, so it's 3. 3 eliminates 3 here, so it's 5, which makes this 1. That eliminates 3 and 8 here, so it's 7. 3 eliminates 3 here, so that's 8, which means this is a parity line. 5 eliminates 5 here, so that's 9, which makes that 5. That leaves us 3 in row 9 and 9 in row 8. 8 eliminates 8 here, so it's 5 and 8. Which eliminates 8 here, so it's 1 and 3. So this is odd, this is even, this is odd. We just have 4 and 5 remaining in row 1. This can't be 5 because of 5 in the column, so this is even, which makes this odd here. So this is 4, that's 5. 4 eliminates 4 here, so it's 8 and 4, which eliminates 8 here, so it's 1 and 8. Again, this is even, and this is odd. Remaining digit here is a 3. It's a 3. Remaining digit here is a 1. And that's how you solve it. Pretty interesting, actually. I'm kind of curious to see. It's pretty restrictive, though, since they cannot match both requirements on any part of the line. They must match one in exactly one condition. So it's a pretty restrictive rule set in that sense. It was interesting. It was interesting solve either way. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.